Right, here's our second video about freefall. This one is going to be an example problem of an object kicked straight into the air. We're going to look at two cases, one where you're asking how high does it go, the second asking what's its total hang time. All right, so let me see. So we'll call these hang time problems, which should be a little bit familiar because we just talked about this, didn't we? All right, so let's take a look at what a picture of this might be. Okay, I don't know what kind of ball I'm drawing, but there you go. All right, so it goes straight up. Now, because it is vertical, we don't call it delta x, we call it delta y. And for the first question, how high does it go? That's what we're looking at. It says a football is kicked straight up in the air at 15 meters per second. We want to know how high does it go. Let's start by writing out our variables. You can fill those in. Final velocity, initial velocity, time, acceleration, and delta y. All right, the first number it gives us is 15 meters per second, and that's the beginning of our story. So there we go. Make this a little bit smaller. Okay, the next number it gives us is, well, it doesn't give us anything, so let's just keep going, see what we can figure out. That's the number. The question is, how high does it go? That's our delta y. And then, so we got to figure out at least two more numbers. So in other words, we're looking for code words. All right, so if it's kicked straight up in the air, that's kind of a code word for free fall. And if we know the code word for free fall is, that's free fall, we know that the object will be going down, so it's negative. The acceleration would be pointing towards the earth, and there is our value. We need one more value. So, and that is going to be our final velocity. So here's the idea. If you throw something up into the air, what's its velocity going to do? All right, as it goes higher and higher and higher, that velocity is going to decrease until it gets to the peak. And then once it hits the peak, it becomes 0. And that's the point where it turns around and it comes back towards the other side. So we know how high does it go, your final velocity will always be 0. Okay, this one does not ask us about time, so we don't need that. And the equation we're going to use that does not have time in it is final velocity squared is equal to initial velocity squared plus double my acceleration and my displacement. I'm going to rearrange that. The first thing we're going to do is subtract the initial velocity. Okay, keep this in parentheses. We still got some math to do. And I'm going to solve for the displacement. So I end up with final velocity squared minus initial velocity squared divided by 2 times a. That becomes 0 squared minus 15 squared divided by 2 times negative 9.8. Kind of cool there. You see how those negatives minus the negative are going to cancel out. And we are left with 11.48 meters, which is about 11 meters. And that is how high does it go? The second type of thing you want to answer when you get this type of question is, well, how long is it in the air? So we have two parts, right? We got the up part and we got the down part. Let's look at the up. So looking at the up part, okay, that means we're on this, okay? Now, this part is going to look very similar to the last problem. Start with your variables, final velocity, initial velocity, time, acceleration, and delta y. And if we know if it's going up, everything that we know so far, we know that it travels 11.48, excuse me. It travels 11.48 meters. We know that it was a free fall, right? So it's negative 9.8 meters per second squared. In this case, we know that the initial velocity was, 15 meters per second, and the final velocity was 0 because it was the up version, right? Going up. In this case, we have all the variables that we need, and we have more variables than we need, so we can just choose whatever equation we want that has a t in it. In my opinion, the simplest equation that has a t in it is final velocity is equal to initial velocity plus acceleration times time. And we're going to solve for time. Start by subtracting initial velocity from both sides. And you're left with final velocity minus initial velocity divided by acceleration is equal to time. Keep working that out. Final velocity is 0 minus 15 divided by negative 9.8, and that gives us 1.531 seconds. That is our up. Now it's time for our down. Okay. Let's see, things that we might know on the downs. Do our variables, final velocity, initial velocity, time, acceleration, and delta y. All right, we know our delta y is going to be 11.48. Okay, now this time it's going down, right? So it's losing that 11.48 meters. It's a free fall problem. So negative 9.8 meters per second is our acceleration. Now, time is what we're looking for. We need one more piece of information. We need to have final or initial velocity. All right, so now let's take a look at this. I'm going to draw a little bit here. Now we're doing here, and it's going down. Okay. All right, so in this case, what is our initial velocity? Well, if at the peak, we know that initial velocity is equal to 0. So our initial velocity, we've switched. Our initial velocity is now 0 meters per second. All right, problem solving time. So we've got, so the only variable we're not using is final velocity. The only equation without final velocity is displacement is equal to initial velocity times time plus 1/2 acceleration times time squared. First term goes away because that initial velocity is equal to 0. Our displacement, whoops, it should be delta y, shouldn't it? Delta y should be equal to 1/2 acceleration times time squared. And so how do I rearrange this? First I get rid of the 1/2, I multiply both sides, so it's 2 times delta y. Then I need to get rid of the acceleration, so I'm going to divide both sides by acceleration. And then I have to get rid of the square. I'm going to do the square root. And that will leave me with time. So math-wise, I'm dealing with 2 times negative 11.48 meters divided by negative 9.8 meters per second squared. Okay, when you do that, you end up with 1.531 seconds. Kind of cool, isn't it? Look at their same values. So what's the total hang time? Is 1.531 plus 1.531, and that'll be equal to 3.06, which is 3.1 meters. Okay. And to quote a teacher friend of mine, what's the moral of the story on this one? Okay. Is that free fall is symmetrical, so that when you are on level ground, your time up is equal to your time down. Okay. And if you think about it, if you come on back up, if we're starting off with 15 meters per second, what do you think that final velocity is going to be on the way down? The final velocity will be the same, because everything, if the time up is the same as the time down, then the velocity at the beginning has to be the velocity at the end, given away directions. So we know that our final velocity will be the negative of our initial. All right, thanks very much. We'll have one more video on this stuff.